this is the control register port number where I have to write this. Now I have to keep a counter. Let me keep it in B, which will be 16. So when it becomes 16, then I have to initialize it to 0 again. And I can keep this in HL pair, this value. So let's see with what instruction I can do it, using LXI H, 7200. These two are clear? This is my counter, which is 16. 10 is 16. And I am loading the address from where I have to fetch this in HL pair. Now I have to take one by pair, then display it accordingly. Let's see how to do it. Firstly, I will move the content of HL pair to A, because everything needs to be brought into A for display. And then I can do out 0, 0. So for the first time it will be what? It will be the first value, that is C0. C0 is now in A and I am doing an out to port 0. Port A. Then I have to do a call delay. Okay. After doing this, what I need to do? I have done for this. I have to move to the next one, and at the same time I have to check whether I have reached the last point or not. So first let us move to the next one by incrementing H. So through INX I have to do it for register pair. So I do INX H. One I have already done, so I will decrement this DCR B. Jump if not 0. If it is not 0, right? If it is not 0, then where I should go? I should again go here, because I have already incremented it. See, I have incremented B, I have incremented H, decremented B. So once I have done that, I have to check whether I have completed for all. If I have completed for all, I will again reset it. I will come here, but I have not done that. It's still, now it is 50. So I will go where to fetch the next element, because I have already implemented H. H is pointing the content. So now it is 7201. So this, let's say up. So jump if not 0 to up. Okay. Once it is done, decrement B, jump if not 0, then what I have to, I need to again do the same thing. So just do a jump to this location, right? Yeah. For again, for repeat or again, whatever you say. So this is the simple code for displaying this 7-segment display. The value from 0 to F and again 0 to F. How? It will start here with 0. In 7200 I have 0's code. So it will display that call delay. It will increment H, it will decrement B, and it will check whether it is 0 or not. It's not 0. If it is not 0, it will go to up again. Again it will take the next value, that is 7201, and again it will display. Again call delay, again do. It will do the needful till F. When it becomes F, this becomes, DCR becomes 0. Okay. When it becomes 0, then this, it's not, jump if not 0. So it is not 0, it is 0 now. So if it is 0, it will go to the next statement. And in the next statement, what it will do? It will actually go to this again. So again, B will be initialized with 10, and the same process will get repeated again and again. Okay? So this is what you have to do for 7-segment display. Now see, this is a fairly simple code starting from 0 to 1. Now I can ask you anything. Let's say I will tell you display multiple of 2 or display something modulo 2, something like that. So you must know what is the logic to do it. This is a simple thing how to do it. In the same way, you have to store those values here and then you have to display it. That is the only thing. The only thing is that you have to calculate what you need to display and then store it somewhere and then display it one by one by one. Either it is multiple of 2 or it is multiple of 3, whatever it is. Okay? So this is what I wanted to discuss for 7-segment display, and we are done with LEDs and we are done with 7-segment display. So the next topic that I will be going through will be, of course, switch. Prior to that, I will be discussing some more other aspects of interfacing. Thank you. Okay, so in this lab, Frank will be actually telling you regarding the experiment. The experiment is very simple, but you need to understand a few things prior to that. So the experiment, what you will be doing, this is an LED. Okay, this LED you have to make it on for certain period of time and then you have to make it off. On and off. How can you do that? All you need to do is that you have to send a code which will on the LED, then you call the delay. Then again you send a code to switch off the LED and then again you call the delay. Okay. So in this process, what will be done? You are sending something to this LED, sending some code which will make the LED on, and then again call delay, and then again send a code to make it off, and then call delay. So Frank, you will be explaining them in detail in the lab. So I will just very briefly tell you, this is anode and this is cathode. Okay. So remember that doing the experiment in the board, it will be like if you do some mistake, the board, this breadboard and this LED all can get damaged. So you have to be very careful and must know before you switch on your switch of this microprocessor. So make sure they don't switch it on unless and otherwise they show all of you the correct connection. Fine. So this is anode. What I said, you have seen the, I believe it will be discussed in the next class, so they might not know this. So let me tell you that the anode will be connected through a resistance to BCC. BCC of the chip 8255. So you know that there are two such chips 8255 in the board. You will be explaining this as well. And the pins are for port A, port B, port C and for BCC ground. Okay. So what we will be doing, this anode we will be connecting through a resistance to the BCC. Okay. So one part of this LED, that is the anode, will be connected through resistance to BCC. Then what we will be sending to the other port should be 0. Then only this LED will glow. There should be a path between, the current flowing path between your anode to cathode. Okay. So in this experiment you will be requiring two such wires. Okay. These are called male-to-male wires, and this is a resistance. Make sure you do the connection properly. So let me show you this connection very briefly. So this is a breadboard and there are some features of breadboard which will be explained by you. So for the time being I am just connecting, this is an anode. So I connect this here. See, I have connected in this way. This is my anode. And what I said, from this pin, now in breadboard these are all connected. These are all connected. So I will just take from here and I will put it here. Okay. Put it here. And here these are connected. So from here again I will take the value and I will connect to the BCC. This side is the BCC. Okay. So I have connected it to BCC. Right. So see, anode through a resistance connecting to BCC. And this is the cathode, the other port. So I am connecting the cathode with ground. See, the LED is glowing, right? So LED will glow when we are sending 0 to the cathode. Okay, so now I have to send this 0 through the port. Through my program now I wanted to do it, right? So for that you have to connect it to port PA0.
PB0.
This, so is this B? This is A, right?
Yeah, pin number 30.
Which one?
From here.
So this is 1,
3,
2, 1, 3, 5, 7,
9,
9, 11, 13.
Yes.
Okay. So now can you run the code? So we have already put up the code here. Now see. This you need to do. Okay. The LED is on and off, on and off. But let's say when the LED will glow or whether your LED is correct or not, you can check this by connecting with the ground. Okay. The LED is glowing, so it is perfect. The connection is all right. And then you can write your code and burn it. So that's all for the lab discussion. You can carry on with this. Okay.